Hi, good afternoon. Can you please confirm my voice is audible?
Yes, sir. Audible, sir.
Thank you. So, as part of morning session, we started discussing about big data concepts and Hadoop concepts. So, we discussed about what is big data. Then we discussed about what all are the 5 different P's we are having in the big data. Then we discussed about some features of big data. And after that, we started discussing about Hadoop framework. So, within the Hadoop, we are having the storage component and we are having the processing component. Within the storage, we are having HDFS. In processing, we are having the MR, or we can able to call it as a MapReduce. And we discussed about what all are the key characteristics of HDFS. And we discussed about MapReduce, key characteristics of MapReduce. And we discussed about within the Hadoop ecosystem, what all are the tools available, or we can able to call it as a Hadoop stack. So all these are the topics we covered as part of the morning session. Now we'll start discussing some new topic. First, we'll try to understand in MR or in MapReduce how execution will happen. So, as part of using the Hadoop, initially we are using the MR, or we can able to call it as a MapReduce. And as part of MapReduce, we need to understand how execution is going to happen. Once we can able to understand how execution is going to happen within the MapReduce, then it is very easy to understand what are the disadvantages we are having in the MR. With that, we can able to easily understand why we are going to use the Spark as part of our real-time data processing instead of using the MR. But if you want to understand all these things, first we need to understand how execution is going to happen as part of the MR. With that, we can able to understand all the remaining topics very, very easily. So here we'll take one example called as word count program. So as part of this program, what will happen is we'll have a file, and file contains multiple words. So here requirement is calculate how many number of times.
Sir, your voice is too low.
Is it fine now?
Yeah, okay.
Everyone having the same problem? I'll go to one first. Is it fine now?
Yes, sir. Fine, sir.
Yeah, okay.
Yes, sir. Okay. So now requirement is we need to calculate how many number of times each and every word is repeating. So this is the requirement. So we are having a file. On top of this file, we are having the multiple words within the file. Requirement is we need to calculate how many number of times each and every word is repeating. That is the requirement. Now we need to find out all this information with the help of the MR program, or with the help of the MapReduce programming. We need to perform all these kind of activities. With that, we need to get the result. Now, as part of this MR programming, first step is nothing but we need to read the file. Second step, we need to flatten the file, or we can able to call we need to flatten the words. So as part of this process, first we need to read the data from the file. After that, we need to flatten the file, or we can able to call it as we need to flatten the words. Now third step is for each and every word, we'll map value as 1. So for each and every word, we'll map value as 1. For example, my file is having hello Srinivas. Then what I will do here is I will give it as a hello 1. Then I'm giving one more as Srinivas 1. So like this, what we are doing here, whatever the number of words we are having, we are going to flatten all the words. For each and every word, we are mapping the value called as a 1. After that, we are going to perform aggregate operation on top of key value. With that, we'll count how many number of times a word is repeating. So all these are the steps which we are going to perform as part of our MR programming. Now here I'm not going to show you the MR programming only because Anyhow, in the real time, we are not going to use the MR programming. In the real time, we are going to use the Spark only. But we need to understand in Hadoop already we are having the MR. Then why we are going to use the Spark as part of real time? If you want to understand that, first we need to understand how programs are executing as part of MR, and with that we can able to understand what is the disadvantage of MR. With that, we'll try to understand what are the advantages we are having in the Spark and why we are using the Spark as part of our real-time projects. To understand all that, here we need to focus about how execution is happening on top of our MapReduce programming or MR programming. With that, we can able to understand all these things. For that reason, just I'm putting the steps here. What are the operations is going to happen as part of our MR programming? First step, we need to read the data from the file. After that, we need to flatten all the words in the file. After that, for each and every word, we need to assign the value as a 1. On top of that, by using the key values, we are going to perform the summing operation. With that, you can able to get how many number of words for each and every word. You can able to get the information, how many number of times it is repeating. To understand that information, we are going to perform all these kind of steps. Now, just I will show you one small diagram. So just to try to understand this diagram only. So by using this diagram only, we are going to understand about what are the disadvantages we are having on top of the MR. Now, for example, your file is having the content like this: Hadoop, Spark, Hive, Scoop, Hive, Scoop, Hive, Hadoop, Hive, Scoop, Hive. For example, this is the content we are having on top of your file. Now, as we discussed, what is going to happen as part of the first step? If you see the first step here, first step is nothing but reading the data from the file. From this file, it is going to read the data. After reading the data, in the second step, what is going to happen? It is going to perform the flattening in the file, which is nothing but whatever the data we are having in the file, each and every word is going to flatten like this. In this file, we are having Hadoop, Spark, Hive, Scoop, Hive. So this data is converting like this. Hadoop is a separate line, Spark, Hive, Scoop, Hive. Flatten is nothing but whatever the data we are having in the file, it is flattening into the individual words like this. In the same way, if you see the second block, here also we are having some data. This data also flattening like this. It is flattening like Scoop, Hive, Hadoop, Hive, Scoop, Hive. So like this, first step, it is reading the data from the file. After reading the data, entire data is flattening into the individual words. After that, what will happen here is, for each and every word, we are mapping the value called as a 1. If you see, we are giving Hadoop, 1, Spark, 1, Hive, 1, Scoop, 1, Hive, 1. So like that, for each and every word, we are mapping the value called as a 1. After that, on top of this result, we are going to perform the sorting operation. Once we are going to perform the sorting operation, all the values are coming in the sorted way. After getting all the values in the sorted way, now on top of the key value, we are going to perform the aggregate operation. Now in this example, if you see this block, what is the key value? Key is a Hadoop, value is a 1. Key is a Spark, value is a 1. Key is a Hive, value is a 1. So this data indirectly we can able to call it as a key value. Now on top of, based on the key value, we are going to perform the aggregate operation. Now if you observe, come into Hadoop, how many times it repeated? Hadoop 1, again Hadoop 1, which is nothing but Hadoop repeated 2 times. So we are going to get the output called as a Hadoop, 2. Coming to Spark, we are having the Spark only 1 time. You are going to get the value as a Spark, 1. Coming to Scoop, we are having Scoop 1, Scoop 1, again Scoop 1. Based on the key value, if you are going to perform the counting operation, Scoop repeated 3 number of times. We are getting the value called as a 3. Coming to Hive, Hive 1, Hive 1. So like that, it is repeating total 5 number of times. With that, for Hive, you are going to get the value called as a 5. So overall in this process, step 1, it is reading the data from the file. Second step, it is going to perform the flattening operation on top of your file. Flattening is nothing but based on the space delimiter, all the words are splitting like this. After that, we are applying the 1, or we can able to call it as, we are mapping the value called as a 1 for each and every word. With that, we are populating the key value pairs. After that, this entire data we are sorting. After sorting the data, then we are going to perform the grouping operation on top of the key value. With that, you can able to get the final result. All these are the operations we are performing as part of our MR programming. Again, I'm repeating. Step 1, reading the data from the file. Second step, flattening all the words like this. After that, for each and every word, we are mapping the value called as a 1. After that, we are going to perform the sorting operation. On top of that, we are going to perform the aggregate operations based on the key values. With that, for each and every word, you can able to understand how many number of times it is repeating on top of your file. Now, if you go back to the requirement, what is the requirement? Calculate how many number of times each and every word is repeating. That is the requirement. As part of this whole process, at the end, what we are doing here, or what we are getting, for each and every word we are getting how many number of times it is repeating for the purpose of getting the data. Now, in this whole process, what we are doing, we are performing kind of data processing operation. What is the data processing operation we are doing? We are retrieving the data. After that, we are mapping the data with values as a 1. After that, we are sorting the data. After that, we are going to perform the aggregate operations. With that, we are going to get the final result. Indirectly, we are going to perform the data processing operation on top of these 4 steps only. Now, you tell me, in the Hadoop side, if you want to perform data processing operation, what is the component we are going to use? Are we going to use HDFS, or we are going to use the MR?
MapReduce.
For the purpose of doing the data processing operation, obviously we need to use the MR, or we can able to call it as a MapReduce. Now, indirectly, I'm trying to explain in this whole process. Just I'm showing you everything in the diagrammatic format. But here, what we need to do, actually, we need to write the MR program. But as part of execution of the MR program, internally, what is going to happen, that I'm trying to explain here. Now, on top of this, we need to understand. Whenever data reads are going to happen, or whenever data loads are happening, tell me, your data will load into the only single node, or your data will load into the multiple nodes?
Multiple nodes.
Obviously, your data will load into multiple nodes in parallel. This is one important thing we need to remember at any point of time. If you are talking about the storage, or if you are talking about the processing, obviously we can able to say your data is processing in parallel, or your data is loading in parallel. Okay. Now, in this example, we are reading data from file. Now, you tell me here data is coming from single node, or it is coming from multiple nodes as part of reading the data. Any guesses? We are reading the data from the file for the purpose of doing our data processing operation. As part of doing the data processing operation, what is the step 1? We need to read the data from the file. As part of reading the data from the file, your data is coming from the single node, or your data is coming from the multiple nodes?
Single node.
Obviously, we can able to say your data is coming from multiple nodes. Your data is coming from multiple nodes. What's the reason? Whenever we are going to read the data on top of the Hadoop, indirectly where we are having this data, your data is present in the HDFS, or we can able to call it as a Hadoop distributed file system. Now, from the HDFS, you are reading the data. Now, indirectly, as part of storing the data also, in HDFS, what will happen? Your data is storing into the multiple nodes only, which is nothing but indirectly. If you are going to perform the read operation, automatically what we can able to say here, your data read is happening automatically on top of your multiple nodes. To understand that, if you observe here I given the 2 different blocks only. This is the block 1, this is the block 2. Indirectly, you can able to assume that this is the node 1 and this is the node 2. But here we are dealing with a single file, or we are dealing with the multiple files? We are dealing with a single file only, but that single file data distributed to the multiple nodes. This is the node 1 and this is the node 2. And in your file, for example, total we are having the 4 lines. Just assume that 2 lines are loaded into the node 1, two lines are loaded into the node 2. Indirectly, your data is loading into the multiple nodes. From the both the nodes, we are going to perform the data processing operation. Now on the node 1, it is performing data processing operation. On top of node 2 also, it is going to perform the data processing operation. Now if you observe overall as part of this example, we are going to perform different transformations. As part of this example, we are going to perform different transformations. First one we can able to call it as nothing but flattening the data. Second operation we can able to call it as map operation, or we can able to call it as mapping the data. After that, we are going to perform sorting the data. Then we are going to perform the operation called as a reduce operation, or we can able to call it as a aggregate operation. Indirectly, all these 4 different operations are we are going to perform the 4 different transformations on top of your data. First step, obviously we need to read the data. After reading the data, we are applying the transformation called as flattening the data. On top of that, we are going to perform the map operation. On top of that, we are going to perform the sorting operation. On top of that, we are going to perform the reduce operation, or we can able to call it as a reduce transformation. Now, here what will happen is, whenever we are going to read the data, your data will store in RAM. What is the meaning of RAM? RAM is nothing but our random access memory, or we can able to call it as nothing but simply our in memory. So whenever we are going to perform the data read operations, what is happening here? Your data is storing in the in memory location, which is nothing but within the RAM, your data is storing. Now, on top of this in memory, we are applying transformation 1. On top of this in memory, we are applying the transformation 1. What is the transformation 1? We are performing the flattening the data. Flattening is nothing but by giving the space as a delimiter, we are splitting all the words into the individual words only. That operation we can able to call it as a flattening the data. After performing this flattening operation, your data will write to hard disk. Where your data is writing, your data is writing to your hard disk. After writing the data to the hard disk, again we are going to apply our transformation. Here, what is the second transformation we are applying? We are applying the transformation called as a map transformation. With the help of the map transformation, what we are doing, for each and every word, we are applying the value called as a 1. That operation indirectly we can able to call it as a mapping operation, or we can able to call it as a map transformation. Now, after performing the transformation 2, again what will happen is, your data will write to hard disk. After that, we are going to perform sort operation. After performing the sort operation, or we can able to call, this is our transformation 3. As part of transformation 3, we are going to perform the sorting operation. After sorting operation, again your data will write to hard disk. After that, finally we are applying the transformation called as a reduce transformation, or we can able to call it as transformation 4, which is nothing but our reduce operation. Now after this also, again what will happen? Your data will write to hard disk. And after doing all these operations, then finally we are going to get the result. Actually, as part of our MR programming, this is the way your whole program will run internally. And step 1, it will read the data. After that, it is storing the data into the RAM. After that, it is applying the transformation 1. Then your data will be writing to the hard disk. Then again, it is going to apply the transformation 2. Again, your data will be writing to the hard disk. Again, it will apply the transformation 3. With that, again, your data is writing to the hard disk. Again, transformation 4 is going to apply. With that, again, your data will write to the hard disk. Then finally, what will happen? We are going to get the final result. But if you observe here, in this whole process, for each and every step, what is happening? As part of this whole process, for each and every step, what is happening? We are hitting hard disk. Indirectly, we are going to perform IO operation on top of hard disk. The question is, if you are going to perform operations on hard disk, will it give best performance? Or if you are going to perform operations on top of in memory. In memory is nothing but it's a kind of a RAM. Will it give best performance? Just try to give the answer. If you are going to perform the operations on top of the hard disk, will it give the best performance? Or if you are going to perform the operations on top of your in memory, will it give the best performance? Which one is going to provide the best performance? Any guesses?
RAM.
Hard disk.
Hard disk.
We can able to say answer is nothing but RAM. So on top of the RAM, if you can able to perform your operations, that is going to provide the best performance compared to your hard disk. Now see, for example, I opened one Word document. Just assume. Okay, so first time when you are going to open the Word document, from where we are going to open this Word document? From the hard disk, we are going to open the Word document. Now tell me, first time when you are going to open the Word document from the hard disk, how much time it will take generally? We can able to think 4 to 5 seconds. Because first time you are going to open one Word document, from the hard disk you are opening this Word document. So what will happen? For the purpose of opening this Word document, it is going to take 4 to 5 seconds. Now for example, after opening that Word document, you want to see Word document one more time. Here what happened already? Already you open this document. Now just you want to see this document. So what we can do here, already in the taskbar, you can able to see your open Word document. By using the document, you can able to see the content. So with that, what will happen? You can able to see the data. Now, for example, I open Word document like this. Now tell me, if I want to open this document, what I can do simply here? Just I can come to the taskbar. In the taskbar, I'm going to open this document. Whatever the document you are going to click, automatically that document is going to open. Now you tell me, from the taskbar, if you are going to open this document, indirectly you are opening this document from the hard disk, or you are opening this document from the in memory.
In memory.
Any guesses? From the taskbar, whenever you are going to open one document, that is nothing but indirectly you are opening the document from the in memory only, which is nothing but already you open the document from the hard disk. Now this document is using your in memory. Within the in memory, your data is storing. Now from the in memory, you are trying to open this document. Now by click on this, what will happen? Within the milliseconds only, you can able to open the document. Indirectly, we can able to say, if you want to do the operations directly on top of the hard disk, it will take more amount of time. But if you want to perform the same operation on top of your in memory, that is going to take the very less amount of time, or it is going to provide the very best performance. Indirectly, we can able to say, compared to the hard disk, on top of in memory or on top of the RAM, if you are going to perform any kind of operation, that execution is going to happen very fastly compared to your hard disk. But as part of MR programming, as we discussed here, what's happening? On top of every transformation, it is going to hit the hard disk for the purpose of storing the data. Transformation 1, it is going to hit the hard disk. Transformation 2, it is going to hit the hard disk. Transformation 3, hard disk. Transformation 4, hard disk. Indirectly here we can able to say, as part of using MR program or MR component, for each and every transformation, it will hit hard disk internally. Because of that reason, MR component is providing very bad performance. So because of the reason, MR programming or MR component is providing the very bad performance only. Now simply we can able to say, to overcome this issue, a new framework launched, which we can call it as Spark. So to overcome this issue or to overcome this kind of performance issue, a new framework is launched. So simply which we can able to call it as nothing but Spark. Now with the help of the Spark also, we are going to perform the similar kind of operations as part of our example. But as part of Spark, what will happen here is Spark will do all the operations on in memory only. So what is going to happen? Whatever the operations, or we can able to say, whatever transformations are going to happen on top of your data, all the transformations are going to happen on top of your in-memory only. Indirectly, it is not going to hit the hard disk only. All the operations or all the transformations are going to happen on top of your in-memory only. But when it is going to happen, when we are going to use the Spark as a framework for our data processing operation, at that point of time, all the transformations are happening on top of your in-memory only. Because of this reason, we can able to see 100 times cost performance compared to MR. So just now, whatever the example we discussed, from the local system or from the hard disk, if you want to open one Word document, it will take a lot of time. Instead of that, if you are going to open from the in-memory, within the milliseconds only, you can able to open the document. Same thing is applicable on top of your processing the data also. Because of hitting your hard disk multiple number of times, MR is going to take the good amount of time compared to the Spark. But if you are going to compare the MR and Spark, what we can able to see here, Spark is going to provide 100 times fast performance compared to our MR. What is the reason here? Are we doing any magic as part of the Spark? We are not doing anything here. Within the Spark framework, it is going to perform all the transformations on top of your in-memory. Because of using the in-memory transformation or because of doing the in-memory operations, it is performing all the operations very, very fast compared to our MR. That's the reason nowadays most of the people are using the Spark for the purpose of doing our data processing operations. Okay. Before Spark, I can able to say, before Spark, to process data on top of Hadoop, we used MR only. At that time, people are thinking that MR is given the best performance, but after seeing this kind of disadvantages, a new framework was built that we are calling it as a Spark. Once a Spark got introduced, then what happened? Most of the people started using the Spark because of giving the best performance. How it is given the best performance? Because Spark is going to do all the operations on top of your in-memory only. Because of this in-memory operation, Spark is going to provide very best performance compared to all other data processing engines. Okay. Any questions up to here? Please ask me. Any questions up to here? Now, if anyone is going to ask the question, how Spark is going to provide the best performance, simply we can able to say, because of the in-memory operations, it is going to provide the best performance compared to the MR. That is one answer we can able to say. And one more answer is nothing but Spark is given the feature called as nothing but, or Spark is having lazy evaluation feature. Which is nothing but you are applying, for example, 10 transformations. All these transformations will not trigger immediately. Then when it will trigger? Once we are going to call any actions, then only it will trigger all transformations. This kind of operation only we can able to call it as nothing but lazy evaluation, or we can able to call it as a lazy operations. And for example, you are applying the transformation 1, then you are applying transformation 2, then you are applying the transformation 3, then you are applying the transformation 4. After that, at the end, we are applying the action 1. So now actually in the MR, what will happen? First transformation will complete 1. Then we are applying the transformation 2, then we are applying the transformation 3, then it is running the transformation 4. So like this, that is the way it is running each and every transformation one by one. But coming to Spark, what will happen here is you are writing all the transformations, but all these transformations will not trigger immediately. When it is going to trigger, whenever we are going to call a action, then only it is going to trigger all these kind of transformations. Indirectly, we can able to say all transformations will wait for an action. once action is going to trigger, then only what will happen? It will trigger all the transformations on top of your execution. That kind of operation only simply we can able to call it as nothing but lazy evaluation, or we can able to call it as a Spark is providing the feature called as a lazy feature. As part of lazy feature, it is not running all the transformations immediately. Whenever we are going to call the action, then only it is going to trigger all the transformations one by one. With that, it is going to provide the best performance as part of our execution. That is the one thing we need to understand. One more thing is nothing but as part of Spark execution, it will run from bottom to top approach. What is going to happen? It is running from bottom to top approach indirectly. Whenever we are going to call the action 1, it will go to transformation 4. Transformation 4 will verify transformation 3. Transformation 3 will verify transformation 2. Transformation 2 will verify the transformation 1. That is the way your execution is going to happen on top of our internal system only. But coming to MR program, what's happening? It is coming as a top to bottom. Transformation 1 will complete, then transformation 2 will trigger, then transformation 3 will trigger, then transformation 4 will trigger. As part of MR programming, it is coming as a top to bottom, but as part of Spark, it is coming as a bottom to top approach. At the same time, Spark is providing the feature called as a lazy evaluation feature. One more important thing we can able to call it as nothing but coming to Spark, we are having the lazy evaluation feature. And one more important thing, within the Spark, it is going to perform all the operations in memory. Because of that reason, it is going to provide very best performance compared to our MR programming. And now by considering all these things, you try to give the answer. What all are differences between MR and Spark? Try to give the answer here. Based on our whole discussion from last 20 to 30 minutes, you try to give the answer. What are the differences between MR and Spark?
MR is going to perform low.
So we can able to say with the help of MR, we are going to get the low performance. But coming to Spark, we can able to say it is going to provide
High
performance, or we can able to call it as a high performance. What next? As part of MR, what is happening? Multiple times.
Store the data in.
It is hitting hard disk. I'm giving the shortcut as a HDD. HDD is nothing but our hard disk. But coming to Spark, what's happening? It is running
RAM
in
memory.
Transformations on in memory
to RAM.
Or we can able to call it as a RAM. Okay. So because of this reason only, we are going to see the good performance on top of your Spark. Okay. This is one thing. And what other thing we can able to say here? Third one. As
Spark is user friendly.
As part of MR, we can able to say it is going to perform top to bottom execution approach. Whereas coming to Spark, what's happening here? It is performing the bottom to top execution approach. And last one we can able to say, as part of MR, it is going to perform the linear execution. But coming to Spark, we can able to say it is going to provide the lazy execution, or we can able to say it as a lazy evaluation feature. So like this, we are not inventing any new thing only. Based on our discussion, just we are saying that what are the differences between the MR and Spark. MR is going to provide the low performance compared to Spark. And coming to MR, multiple times it is hitting the hard disk, but coming to Spark, it is running all the transformations on the in-memory only. Because of the reason, within the minutes or within the seconds only, your programs are going to complete. After that, coming to MR, it is going to perform the top to bottom execution approach. But coming to Spark, it is going to perform the bottom to top execution approach. One more important difference, coming to MR, it is going to perform the linear execution, which is nothing but if you are applying the transformation 1, it will immediately apply the transformation 1, then it will apply the transformation 2, then it will apply the transformation 3. But coming to Spark, what's happening here? It is going to perform the lazy evaluation, which is nothing but if you are writing the 4 transformations or 10 transformations only, when all these transformations are going to trigger, whenever we are going to call the action, then only it is going to trigger all the transformation. That kind of operation only we can able to call it as a lazy evaluation. And one more important thing, someone saying that we can able to say in MR, we need to write very complex programming. But coming to Spark, We can able to write very simple programming. That's the reason here simply we can able to say this is a kind of a user friendly. Someone is giving the answer user friendly, but how it is user friendly? For the purpose of achieving the same above example, in the MR, we need to write around 150 to 200 lines of the code, but within the Spark, within the 3 to 4 lines of the code only, we can able to perform the word count operation. That is the kind of a simple programming we can able to write on top of our Spark. At the same time, Spark is the kind of a user friendly because of writing the very less number of lines of the code. We can able to say Spark is nothing but it's a kind of a user friendly framework. Now this is the way simply we can able to understand what all are the differences between MR and Spark. Now I will ask one question, you try to give the answer. MR and Spark, these two we are using for the purpose of data storage. Is the correct answer or wrong answer?
It's wrong. For data processing.
Data processing.
This is the perfectly wrong answer. Why we are using both? For the purpose of our data processing. Okay, because of discussing these many things, don't forget about the basic things. And MR we are using for the purpose of data processing. Spark also we are using for the purpose of our data processing only. So don't forget about these basic things. MR and Spark purely we are using for data processing, not for data storage. For the purpose of data storage, in the Hadoop, what we are using? We are using our HDFS. Okay, data storage. Now, if anyone is going to ask the question, what is Spark? What we can able to say simply? Just have to do the statement like
Data
this.
processing.
Apache Spark is an open source software. It is an open source study, so no need to pay any kind of money here. It's a kind of a open source, and we can able to say here it's a distributed data processing framework,
Data processing.
which is designed for large scale data processing and analytics. See here on top of this whole statement, we are not discussing any new things. Andy, you say Apache Spark is a kind of a open source software which is nothing but no need to pay any kind of money. And why we are using the Spark? For the purpose of doing our data processing. Why we are calling it as a distributed data processing? As I told you earlier, as part of storage or as part of processing, obviously we are going to append the word called as a distributed. Everything is going to happen in parallel on top of our Hadoop. So that's the reason we are calling it as a Spark. We are using for distributed data processing framework, which is designed for dealing small amount of data or large amount of data. We can able to say we are using mainly Spark for the purpose of dealing with our large scale data processing, or for the purpose of doing our large scale data analytics, we are going to use the Spark. Okay. Now tell me, can we able to use the Spark for the purpose of dealing small amounts of data? Can we able to use the Spark for the purpose of dealing small amounts of data? Obviously we can able to use, but what is the main intention of the Spark? To deal with the very huge amount of data only we are using the Spark. But if you want, what we can do here, we can able to deal the small amounts of data also on top of our Spark. But in real time, we are mainly using the Spark for the purpose of dealing with our huge amount of data as part of our real time projects. Now, if anyone is asking the question, what all are the features of Spark? We can able to give the statement like this. First one, it is going to perform in memory processing. It is going to perform in memory processing. This is the first thing. Second one, we can able to say it's very ease of use. As I told you earlier, so we need to write the very simple programming. It's a kind of a user friendly, or we can able to call it as a it's very ease of use. And next one, we can able to say that it is providing versatile data processing models. It is providing versatile data processing models, like it is providing batch processing, and it is providing stream processing, and it is providing machine learning processing, and also it is providing graph processing. So indirectly with the help of the Spark, we can able to perform all these kind of data processing operations. We can able to perform the batch processing, or we can able to perform the stream processing, which is nothing but we can able to deal with the real-time data, or with the help of the Spark, we can able to perform the machine learning operations, and with the help of the Spark, we can able to perform the graph processing operations. All these kind of operations we can able to perform with the help of the Spark. In the same way, we can able to say one more feature called as nothing but it is providing distributed data processing. What is the meaning of distributed? Internally, it is going to perform all data processing operations in parallel. That kind of operation only we can able to call it as a distributed data processing. And we can able to say with the help of the Spark, we can able to read and write data to different, or I will say like this, we can read data from different sources, and also we can able to write data to different targets. By depending on our requirement, you can read the data from the different types of the sources. At the same time, you can able to write the data to the different types of the targets by depending on our requirement. Here source is nothing but we can able to say like this. You can able to read data from HDFS, or you can able to read data from Hive, or you can able to read data from HBase, or you can able to read data from relational databases, or you can able to read data from cloud systems also, which is nothing but, for example, if you want to read data from GCS, we can able to read, or if you want to read data from S3 buckets of your AWS cloud platform, we can read that, or if you want, we can able to read data from Azure data lake storage also. Indirectly, GCS is falling under GCP, S3 is falling under AWS, ADLS is falling under Azure. You can able to read the data from different types of the cloud platforms also by depending on our requirement. In the same way, as part of writing the data also, if you want, we can able to write data to HDFS, or we can write the data to Hive or HBase or relational databases or cloud system, or if you want, we can able to write the data to BigQuery also by depending on our requirement. With the help of the Spark, what we can do here, from the BigQuery, we can able to read the data, or on top of the BigQuery, if you want, we can able to write the data also. All these operations we can able to perform with the help of the Spark. In the same way, we can able to give the one more statement here. It is having integration with our Hadoop stack, or we can able to say our Hadoop ecosystem components. What is the meaning of the statement? Any guesses? What is the meaning of the statement? It is having the integration with big data components, or we can able to call it as a Hadoop ecosystem component. What are the Hadoop ecosystem components we are having? Morning we discussed, if you remember, these are the Hadoop ecosystem components. What are those? Hive, Pick, HBase, Spark, Scoop, Kafka, Woozy, Flow, and MR. All these are nothing but our Hadoop ecosystem components. And indirectly, with the help of the Spark, you can deal with the Hive, or you can deal with the HBase, or you can deal with the Scoop, or you can deal with the Woozy. All these components we are having integration with the Spark. Indirectly, we can able to say Spark is having the integration with our Hadoop ecosystem component. But tell me here one question: can we able to use Spark only on top of the Hadoop? Is it the correct statement or wrong statement? Spark we can able to use only on top of the Hadoop framework. Is it the correct statement or wrong statement?
Wrong.
We can able to say simply this is a kind of a wrong statement. If you see here what I'm telling here above, with the help of the Spark, you can able to get the data from the relational databases, or you can able to write the data to your relational databases also by depending on our requirement. At the same time, with the help of Spark, what we can do here, you can able to read the data from the cloud systems, or we can able to write the data to your cloud systems also. Otherwise, with the help of the Spark, you can able to read the data from the BigQuery, or we can able to write the data to the BigQuery. But tell me, this relational databases, cloud system, and BigQuery, all these are present in the Hadoop, or all these are present in the outside of the Hadoop? All these are present outside of the Hadoop. And for that reason, don't give any statement saying that Spark is can able to perform all the operations only on top of the Hadoop. That is completely wrong statement. By using the Spark, you can able to perform any kind of operations on top of any kind of tools, and either relational databases or cloud system or BigQuery, on any kind of technologies we can able to integrate with the Spark by depending on our requirement. All these are the features we need to understand as part of discussing about the Spark. Okay. Any questions up here? Please ask me again. Okay, if no questions, now try to give the answer. What about MR? MR, can we able to apply it on the other components, or we can able to apply only on top of Hadoop.
Hadoop.
We can able to say MR is tightly coupled with Hadoop, which is nothing but from the HDFS location only you can able to read the data, or we can able to perform the data processing operations by using the MR. But coming to Spark, we don't have any such kind of limitations, Randy. You can able to perform any kind of operations with the help of the Spark on top of your Hadoop, or on top of your cloud system, or on top of your relational databases. We can able to perform any kind of operations with the help of the Spark. Okay, all these are some of the statements or some of the features we need to understand with the help of the Spark. Okay, now other than all these things, we need to understand few more statements. Just 1 second. We can able to say Spark is very faster compared to MR. Next one, we can able to say Spark works on in memory. Next, we can able to say Spark uses lazy evaluation. Next, we can able to say Spark supports machine learning. And next, we can able to say Spark supports SQL operations. Right? With the help of the Spark, you can do data processing in two ways. One by using RDD, and second one by using data frame. This is the separate topic only. We'll discuss about this topic either in the today's session or in the tomorrow session. Whenever we are going to use the Spark, compulsory we need to understand what is the RDD and what is the data frame, because whatever the programs we are going to run, or whatever the programs which we are going to write, in those programs compulsory we are going to deal with either RDD or we are going to deal with the data frame. For now, just to try to remember, on top of Spark, we can able to perform the data processing in the two ways. One is by using RDD and other one is by using the data frame. What is RDD? What is data frame? And how we are going to write the programs with the help of the RDD and data frame. We'll discuss about these details in very detail as part of today's session in next 20 minutes, or in the tomorrow session, we are going to discuss about what is RDD and what is data frame. In the same way, we need to understand. If you want to write the Spark program, we can able to write the Spark program by using Scala language, or by using Python language, or by using Java language, or by using R language. So it is having the compatibility. Spark can able to support Scala, Spark can able to support Python, or Spark can able to support Java, or Spark can able to support the R language also. By depending on your requirement or by depending on your convenience, we can able to build the Spark programming by using any one of the language only. But as part of our classes, whatever the Spark programming we are going to write, we are writing with the help of Python plus Spark, which we are calling it as a Pyspark. Whatever the Spark programming or whatever the Spark data processing we are going to cover, all those topics we are going to cover with the help of the Python programming language. For that reason only, just we are given the naming convention called as a Pyspark. In the same way, Spark uses different sources and writes data to different targets. As we discussed already, with the help of the Spark, we can able to read data from different types of the sources. At the same time, we can able to write the data to different kind of the targets also by depending on our requirement. Now, one last thing we can able to say, Spark is environment independent, which is nothing but you can able to run your Spark programs on top of your Hadoop, or we can able to run the Spark programming on top of Linux, or we can able to run it on top of Windows, or we can able to run it on top of your GCP, or we can able to run it on top of your AWS, or we can able to run it on top of your Azure also, by depending on our requirement only. Whatever the Spark program we are writing, that Spark program we can able to run on top of your Hadoop or Linux or Windows or GCP or AWS or Azure, on top of any one of these components or on top of any one of these systems, we can able to run our Spark programming. For that reason, we can able to say Spark is nothing but it's a kind of a environment independent. Once you are going to run the program, you can able to write the program on once here. Once we are going to write the program, you can able to run it on any kind of system, either Hadoop or Linux or Windows or GCP or AWS or Azure. On any one of the system, we can able to run our Pyspark program by depending on our requirement. All these are the few more points we need to understand on top of the Spark. Okay. Any question on top of all these statements again, please ask me. Again, if you observe directly or indirectly, already we discussed about all these statements only. Just we are consolidating all the features of the Spark like this. But on top of these statements, if you are having any kind of questions, please ask me. I know it is completely theoretic, but we don't have any other option. First, we need to understand the theory. Once you understand the theory, then we can go for the practicals. Then practicals will become very, very easy without knowing about all these kind of terminologies. If you are going for the practicals, what will happen? You can able to get lot of confusion. For that reason, we are spending good amount of time on top of the theory. Okay, even if you're getting the bore feeling also, you have to understand all these kind of concepts. We don't have any other option. Please try to understand all these points one by one. If you have any questions up to here, please ask me.
Sir, in GCP platform, where we are writing the Spark.
On top of data prop. If you are from the batch 19 only, coming to batch 19 people, we discussed about data prop, right? In the data prop, if you remember, I showed you how we can able to open the Spark or how we can able to write the Spark SQL. We done all those operations on top of your data prop. With the help of the data prop, you can able to run all your Pyspark programs in the GCP side. Coming to batch 20 people, we have discussed about the data proc so far. When we are going to discuss about data proc, I will show you how we can able to run the Pyspark on top of our GCP data proc service. But coming to batch 19, already we discussed in the data proc, we can able to run our Spark applications by depending on our requirements. Any other questions up to here? Okay. If no questions, Sandy, now we'll do one thing. Morning, we did the Spark setup in our local system, or we can able to say from the command prompt, we did the Spark setup. Now what I can able to say is, if you want, we can able to run Spark programs by using PyCharm IDE also. Actually, in the real time only. So as part of doing the development activities or as part of writing the code in the dev environment, one option you can able to use the command prompt. Other option, if you want, we can able to write all our Spark programs by using our PyCharm IDE. But I can able to say out of these two things, command prompt and PyCharm, I can able to say most of the times we are going to use this approach. But tell me, what is the difference between the command prompt and PyCharm? From the Python perspective, if you remember, what is the difference between the command prompt execution and PyCharm execution? In command prompt, what we can do here? We can able to run one by one line program. But coming to PyCharm, what's the advantage? You can able to write the multiple lines of the program in a single script. With that, you can able to trigger the script by depending on our requirement. Indirectly, in the both the places, we are going to perform the same operation. But in the command prompt, we need to run the one by one line of the code. But coming to PyCharm, what we can do here, you can able to trigger multiple lines of the code at a time by depending on our convenience. And that's the reason, by depending on our convenience, either we can able to go for the command prompt approach or we can able to use the PyCharm IDE for the purpose of writing our Spark programs. But out of these two approaches, I'm saying that in the real time, most of the times we are going to use the PyCharm for the purpose of writing our programming. And other than these two approaches, we are having the one more approach called as a notebook approach. If you remember, as part of Python writing on Python programs, what we did, we ran the Python program from the command prompt. We ran the Python programming from the PyCharm. At the same time, we ran the Python program from the notebook also. By depending on our convenience, we can able to follow any one of the approach only. In the same way, as part of writing the Spark, or I can able to say, as part of writing our Pyspark programming, we can able to do this from the command prompt, or we can able to do this from the PyCharm, or we can able to do this from the notebook also. By using any one of these three options, we can able to write the Spark programming. One more option is nothing but with the help of Databricks. With the help of the Databricks also, we can able to run our Spark programming. We'll discuss about Databricks separately only. Might be tomorrow or after tomorrow we are going to discuss about the Databricks. For now, we'll focus about how we can able to write the Spark programming with the help of the PyCharm. Already in the morning session, we discussed about how we can able to do this activity from the command prompt. I hope most of the people are set up everything in the command prompt. I think 4 or 5 people are facing some kind of issues only, but other than that, all other people are completed the setup in the command prompt. Now we'll try to replicate same thing in the PyCharm. Please open your PyCharm. We'll do the setup in the PyCharm. Please open your PyCharm. Once you are going to open the PyCharm, I will show you how we can able to do the required setup. So once you are going to open the PyCharm, here in the file, please in the menu bar, please go to the file. Click on new project. For the purpose of doing our practice on top of the Pyspark, we'll create a separate project ID to avoid the confusions. Just click on new project. In the menu bar, go to file, and in the file, please click on new project. Once you are going to click on the new project, it is going to open the window like this. In this window, it is asking the project name. You can give some name here. I am giving, for example, Spark Practice. Please give some name of your project name. After that, please click on create. After that, please click on create. Once you click on the create, it is asking the question, you want to open the project in the same window or you want to open the project in the new window. Please click on the new window to avoid the confusions. Please click on new window to avoid the confusions. Please click on new window to avoid the confusions. Once you click on this new window, it is going to open the one more PyCharm window. Now you can able to see the two PyCharm windows only. One is the old one where you did the practice on top of your Python. Second one is nothing but we created the new project, and for that project we given the name called as a Spark Practice, or we can able to give the name as a Pyspark Practice. You can able to see the new window like this. Okay. Now next step is nothing but within the PyCharm, we need to install some softwares or some packages only. If you remember how to install the packages in the PyCharm.
From the file
File settings.
Yeah, please go to
settings.
the file. Please go to settings. Within the settings, you need to search for interpreter. Once you search for the interpreter, then you can able to see the Python interpreter. Please go to the file in the menu bar. Click on settings. Within the settings, search for interpreter. Then you can able to see the Python interpreter like this. Within the Python interpreter, we can able to install the required packages. Now, first one, what we have to install here is we need to install the Pyspark only. Please click on this plus button. In the Python interpreter, please click on this plus button. Then search for Pyspark. Search for Pyspark. Select the Pyspark and click on install package. Search for Pyspark. Select the Pyspark and click on install package. I'm not going to click on install package because in my system already Pyspark is available. I installed it. That's the reason I'm not going to do. I'm not performing that activity. Just wait for 30-40 seconds only. It will take 30-40 seconds or 1 minute also. Did anyone thinking why we are discussing the Spark and why we are spending morning session and this session fully theory? It's very simple, and as a data engineer, you should have knowledge on the Spark also. For that reason only we are discussing about the Spark. Okay, don't think like that. Definitely as a data engineer, we should have knowledge on the Spark, because as a data engineer in the real time, sometimes we have to write the Spark programming also. That's the reason compulsory you should have knowledge on the Spark. For that reason only we are spending the time on top of the Spark. Okay. Now, once if installation is completed for the Pyspark, then search
Sir,
for
this interpreter we will go from the run button. It's a run button, right click.
sorry, can you repeat the question? I didn't
This
get that.
interpreter, Python
Mhm.
interpreter.
Mhm.
How we are going here? For
How we are opening
going
this
to
or
this
asking?
Python interpreter.
Or you are not focusing on the class.
No. I did
In the
that
menu
last
bar,
time
we need
also.
to go to file. In the menu bar, we need to go to file. Then go to settings. In the settings, you need to search for the interpreter. Then you can able to get the Python interpreter like this. Okay. Now next step, Andy, other people. Once you are going to install the Pyspark, now you need to install the one more package called as a Find Spark. Please search for the Find Spark. Find Spark. That's my mistake. Where to search? Please click on this plus button. Please click on this plus button. After that, search for Find Spark. Click on the plus button, then search for Find Spark. You can able to see the Find Spark here. Please select that and click on Install Package. Search for Find Spark. Select the Find Spark and click on the Install Package. Indirectly, just we are installing two packages to deal with the Pyspark programming. One is the Pyspark and second one is nothing but Find Spark. With the help of these two packages, you can able to work on the Pyspark from the PyCharm window.
I'm not getting this option to add these packages here.
Click on this. You are not seeing this plus button.
I can able to see, but it is not able to click. So it is showing that nothing to show.
Other people are able to see the plus button, or you are also not able to see this plus button.
Sir, we are seeing it.
No issue, sir.
Person whomever facing the issue, if you see here above, I'm seeing the Python interpreter. Are you able to see this Python interpreter above?
Yeah, I can see that, sir. But here in the box, it is showing no interpreter.
Okay, can you please share your screen? What's your name?
Sai Kumar.
Sai Kumar. Yeah. Yeah, given the permission to you, can you please share your screen? Just quickly we'll check it out.
Yes, sir. Are you able to see this?
Yeah, I'm able to see. Just 1 second. So if you see above in the Python interpreter, nothing is colored. That's the question I asked you, right? Can you please click on the drop down? Click on the drop down. Nothing is here. Yeah, nice. Click on the add interpreter. Add document. Then click on OK here. You are facing the issue today only, or from the beginning onwards you are saying you are facing this issue?
No, sir. As a part of practice for Python, no issue, sir. While installing,
have you installed the pandas earlier from the PyCharm?
no, sir. There also I'm facing issues.
This I need to check on it. So just give me some time. I will check and get back on this. Because I need to replicate the same issue. Then only I can able to find out the solution for this. I will check and get back to you. Is it fine?
Sure. Okay, sir. No problem.
Sir, Pyspark installation complete. What is the another package name?
Pyspark. Find Pyspark. Pyspark. This is the name. If you see my screen, this is the name. Pyspark. Other people, anyone facing the issue for Pyspark and Pyspark. If you people completed the installation of both the things, please let me know. After that, just we need to perform the one more step. With that, we can able to run our Pyspark programs. Completed the installations of both Pyspark and Pyspark.
Yes, sir.
Okay. Yeah. Now, if it is completed already, now below this Python interpreter, you can able to see one more thing called as a project structure. Please click on this. Please click on the project structure. Please click on project structure. See, please follow my instructions very clearly, and then only what will happen, we can able to save the time and we can able to avoid the issues. Because morning also I observed whatever the path I asked you to give. So some people are given the completely different paths. If you are given the different path, automatically what will happen, you will get the issues. To resolve the issues, again, we have to spend half an hour or 40 minutes of time. If you are going to follow all my instructions clearly, then automatically you won't face any kind of issues. That's the reason, please try to follow my instructions carefully. Okay. So please go to the project structure. In the project structure, please click on add content route. If you see here, you can able to see the button called as a add content route. Please click on that. Please click on add content route. Once you click on
project structure option.
Sorry.
I did not find project structure option.
No, below the Python interpreter only, you can able to see the project structure. Other people, anyone face that
It's
issue?
not visible.
It's not visible.
Sir, they can right click on that project Pyspark practice. Right click. Okay, it will show you.
Okay, so someone is giving the suggestion, Andy. Just right click on your project name. If you see here on top of the Python interpreter, you can able to see the project name, and on top of that, just right click. There you can able to see the option.
Okay, got it.
Otherwise, if you click on this project name, here you can able to see the project structure. If anyone not seen the project structure here, on top of the Python interpreter, you can able to see your project name. If you click on the project name in the right side panel, you can able to see Python interpreter and you can able to see the project structure. You can click on that. That is one more way. Otherwise, right click on the project. Once you right click on the project, there also you can able to see the project structure. Follow any one of the approach. Okay, so once you click on the project structure from anywhere, you can able to see the option called as a add content route, and please click on this. Please click on add content route. Once you click on the add content route, it is asking the path. Here we need to provide the path. So please be listen properly here. Morning, if you remember, we renamed one of the folder called as a Spark. In whatever the path you are having that Spark folder, we need to go to that folder by using this option. For example, in my system only, if you see here, in the D drive, under the Qt folder, we are having the folder called as a Spark. Coming to your case, might be in the downloads folder, we are having the Spark, or in the C drive, or in the D drive, or in the E drive, wherever you are having the Spark folder, please navigate to the Spark folder here. In my system, in the D drive, click on this arrow. Then in the Qt, I clicked on this arrow. Then I came to the Spark folder. Then I need to click on this arrow. Within the Spark folder, please come to the Spark folder and wait for a few seconds for other people. Please navigate to your Spark folder, which we created morning. Don't ask me, sir, when we created the Spark folder. Morning we created this one only. We downloaded the Spark package and we extracted or we unzipped that file After that, we rename the folder name as Spark. Now I'm saying that please go to that path by using this window. Now within the Spark, you can able to see one more folder called as a Python ID. Please click on the Python. Beside the Python, please click on the arrow. Within the Spark, you can able to see Python folder. Within the Python folder, you can able to see the lib folder. If you click on the arrow, within the Python, you can able to see lib folder. And within the lib folder, you can able to see one zip file called as py4j src.zip. Please select that file, then click on OK. Again, I'm repeating. Spark, you need to navigate to your own path. Once you are coming to the Spark, within the Spark, we need to go to Python. Within the Python, we need to go to lib. Within the lib, we need to select py4j src.zip. That is the file we need to select. Just to select that file and click on OK button. If anyone facing any issues or any confusions, please let me know. Within the Spark, please go to Python folder. In the Python folder, please go to lib directory or lib folder. Within the lib folder, please select py4j src.zip. After that, please click on OK button. After that, please click on OK button. Again, in this window also, please click on OK button. In this window also, please click on OK button. Okay. So with this, we can able to say in your pie chart, you did the setup for the Pyspark only. Now next step is nothing but Pyspark pie chart is ready with the Pyspark setup. Now just we need to verify our Pyspark programs are running or not. Just I will give you a sample program for today. Sorry. Anyone have any questions? If you are not talking, can you please go on mute? Okay. So now we are having the pie chart. Within the pie chart, we are having the Pyspark setup and everything is ready. Now what we have to do? We need to run some programs in the pie chart. For now, just I will give a sample program. Don't think about what is this program and what are the lines we are having in this program. And the intention of this program is just to verify in your system in the pie chart whether you are able to running the Pyspark programs or not. That is the intention of this program. Don't confuse what are all these lines. From tomorrow morning onwards, we'll discuss about the practicals. At that time, I will explain what is the meaning of all these lines of the code. For now, our intention is just we need to verify whether Pyspark programs are running from the PyCharm or not. That is the only intention. So what you have to do here is you need to create a script file. How to create the script file? How to create the Python script file here or any script file? Just you need to right click on the project. After that, how to create the Python script file? Any guesses?
Go to new.
Click on new. Then click on. Sorry, it's my mistake. Okay. So click on new. So on top of the new, we need to click on the file. And for this file, what is the name we need to provide? You can give any name only. So I'm giving, for example, sample.py. So .py is mandatory. Please give the .py, your file name .py. That is the way you have to create the file. After creation of this file, just I'm giving this code in the Telegram group. Please copy paste. Don't think much about this program. Tomorrow I will explain this whole program. At the same time, tomorrow onwards we'll start the practicals on top of the Pyspark. Today just we are doing the setup only. Whatever the lines of the code I shared in the Telegram group, please copy paste all those lines into your script. please copy paste all the lines into your script.
Sir, in real time, we will install all these packages. So
Yeah, pie chart setup generally we only will do only. So this one your admin team will not come into the picture because this is in our local system, right? So in the local system you have to install the pie chart and you have to do all this kind of setup. Otherwise, they will give a document to you. In the document, they will mention all the steps what we need to do. Simply you can able to follow all the steps, and with that you can able to do the setup for the pie chart. This activity you yourself has to perform in the real-time process also.
Got it.
But in the real time, what will happen is generally whatever the softwares we are downloading, they will not allow you to download the directly softwares from the internet only. They are maintaining one portal. In that portal, they are having all the scanned softwares. From there, we have to download it. With that, all the remaining steps are common. Today morning, what we did, I given one URL. By using that URL, you downloaded the Spark. At the same time, in the Infinity, I uploaded the Java, and from there, you downloaded the Java software. That is the activity we have done in the practice in our institute. But if you are going to work in the real time, what will happen? In the real time company or in the projects, we are going to maintain one portal. In that portal, they will upload all the softwares, and whatever the softwares we need to install, they will upload the softwares by performing all the scanning activities and every activity. From there, you have to download the required softwares. With that, you can need to perform all the remaining steps as part of our real-time projects also. Okay. Now see here.
Okay.
Out of all these lines, Sandy, just you have to perform only one change here. If you observe, here we are giving the one CSV file path for both batch 19 and batch 20 people. I think in the Friday or Thursday, I given one zip file called as x.zip file. In that zip file, if you remember, I given the CSV folder and also I given the JSON folder. In the CSV folder, you can able to see one of the file called as a customer_lo.csv. Please give that path of the file here. This is path in my system, D drive qt dataproc CSV. This is the path from my system. Here, instead of this path, you need to provide your path, and please give the your path here. Sir, where we are having this CSV file? I think Thursday class or Friday class, I shared the one file called as a x.zip file. In that x.zip file, you can able to see the CSV folder and you can able to see the JSON folder. Please open the CSV folder. In the CSV folder, you can able to see the file called as a customer_lo.csv. That entire file path you have to provide here. Only that is the change you need to perform. Except that, don't do any other changes. And once you are going to give this path, just right click on this, click on run program. That's it. Once you modify the path here, you need to right click and click on run program. With that, you can able to run this whole script. Okay, just to see the lines of the code, I will give the just a high level walkthrough only. What we are doing here is, in the step 1, we are reading the data from the CSV file. After that, we are giving the show operation. Show is nothing but it will display the data in your output screen. In the output, you can able to see whole the data in the tabular format. Step 1, we are reading the data from the file. Second step, we are displaying the data in the tabular format with the help of the show command. After that, we are giving the print schema. Print schema is nothing but it will display the structure of the file. What all are the columns we are having in the file? For each and every column, what is the data type? That information we can able to get with the help of the print schema. After that, we are giving the data.count. Count is nothing but it is giving how many number of records you are having in the CSV file. That information you can able to get by using the data.count. After that, on top of this data, we are performing the grouping operation and we are performing the average operation. With that, for each and every city, you are going to perform the average operation. With that, you are going to get the output only. This is the high level walkthrough about what this code is performing. If you are understanding, well and good. If you are not understanding, don't worry. In the tomorrow class, we are going to discuss about each and every line, how to write, what is the purpose of each and every line. Just for the high level glimpse, I am giving the high level information. Step 1, reading the data from the file. Next step, we are displaying the data. Then we are displaying the structure. Then we are printing the count of the records. Then we are performing grouping operation with the average operation. Then we are displaying the result. All these operations we are performing on top of this program. Now, once we are going to give the path properly here, please right click on run button. With that, in the output, you can able to get the output.
Yes, sir, we got the.
You got the output. If you got the output, what it means indirectly?
Sir, it's showing schema, number of rows.
Yeah, you got the output indirectly. What it means indirectly? In your pie
Spark
chart,
is
Pyspark setup
installed.
is perfectly done. And now onwards, you can able to perform the Pyspark programming by using the pie chart.
Sir.
That is the intention of today's session. Tomorrow onwards, we'll start with the programming and we are going to start with the practicals. But intention of today's session is only for setup. If you are getting the output, what it means indirectly, in your pie chart, your setup is running perfectly.
Sir, for me, morning setup is not done yet, sir. Is that fine? Can we use
Yeah, you can
Python?
follow, see, both are completely independent and you can, without morning setup, you can able to continue with this setup. No issues.
Okay, sir.
If you see the output only, first one, it is displaying the data in the tabular format with the help of the show command. With the help of the show command, you are going to get the data in the tabular format. Next one, we given the print schema. What is the meaning of print schema? It is given the structure of your file. It is given the column name and it is given the data types. After that, I given the data.count, which is nothing but it is giving how many number of records you are having in the file. After that, we are doing the group by operation and we are performing the average operation. That result you can able to see here.
This code is Python code, sir.
This is the Pyspark code.
Pyspark code.
Python with Spark. If you observe, we are importing the Pyspark.sql, we are creating the Spark session, and other than that, we are writing the some lines of the code with the Python. Indirectly, you are writing the code with the combination of Python plus Spark, so we can able to call it as nothing but your Pyspark code. If anyone facing any issues in the Python, please let me know. Again, I'm repeating. Morning setup and this setup both are completely independent only. If you are facing any issues in the morning setup, without having any doubt, you can able to proceed with the PyCharm setup. It will work. Don't think that morning is not working. Now today this also not working. It's not the case like that. Both are completely independent. So you can able to set up both the things, or you can able to set up only PyCharm by depending on your convenience.
Hi, sir.
So if
I am getting syntax errors.
Can you repeat that?
Unicode error.
Someone is saying that. Sorry, you're getting the error.
Sir,
Yes, sir.
Unicode error, we can change the slashes to forward slashes.
Yeah, someone gives the session only. So if you are facing the issue for the one slash, please do the double slashes.
All slashes, sir. Single slash.
Yeah, I'm getting that. So this is the way.
Single slash is enough.
No, I give the single slash only. Ready in my code.
Forward to
spelling
backward
forward
slash,
slash.
sir. If we give backward, we should give forward.
We can give R also, sir.
There is
R.
option R. If you provide R, and then
Yeah,
double
someone is
quote.
saying that if you are given the forward slash also, as we discussed earlier, if you are given the or here, that will resolve the issue. So observe here only in my program, I given the forward slashes. For example, sir, backward slashes. If anyone is given the forward slashes before this double quote, just give it as a or. With that, it will work. Otherwise, just to avoid the confusion, please remove all the forward slashes with the backward slashes. With that, you can able to avoid the confusion and you can able to run it. Two options only. One is if you are given the forward slashes before the double quote, please give it as a or. Otherwise, just to remove the forward slashes and give it as a only backward slashes. By using any one of those options, you can able to overcome that error.
So my
And
side,
again, yeah, please.
Pyspark package is still installing.
Still installing. Yeah, please wait for that. So I think might be by depending on the system configuration, it will take some time.
Okay, sir.
And again, just I'm repeating. Don't think that SAR given the code and asking us to run the code and SAR is not explaining. I am only clearly saying that this session intention is only for setup. Okay, tomorrow morning onwards, we are going to start discussing about our Pyspark programming. That's the reason. Don't go with the negative thoughts only. Please go with the positive thoughts.
So if my system doesn't support to install this Pyspark or Spark packages, so can I go with command prompt?
Yeah, you can go ahead with the command prompt.
Because
So-
when I ran the code in command prompt, it ran successfully and gave me the.
Yeah, actually, I'm trying to explain about the multiple approaches which we are going to use in the real time only. For example, in your project, you are not using the pie chart. Your team lead or manager is saying that you have to use the only command prompt, which means you should have knowledge on command prompt. At the same time, in some of the projects, we are going to have the pie chart. If you are going to have the pie chart in your project, then your team lead or manager will ask you that please write the script in the pie chart mode. In that situation, you should have knowledge on the pie chart. So as part of the institute or as part of the classes, I am trying to explain all the possible approaches which we are going to see in the real time. Whether you want to utilize it or not, that's depending on your hands or depending on your system requirements only. But coming to your side, I can able to say if you want, you can able to perform the same practice in the command prompt directly. Otherwise, if you want, you can able to perform the same practice with the help of the pie chart. And I am only saying that in the coming days, might be tomorrow afternoon or day after tomorrow, we are going to discuss about one more service called as a Databricks only. I will show you similar kind of setup in the Databricks also, because in real time, in some of the projects, we are going to use the Databricks for the purpose of running our Spark programs only. For that reason, you should have knowledge on the Databricks also. As a faculty or as an instructor, my responsibility is to explain all the possible approaches we are going to see in the real time. That's the reason I will cover all these approaches. But whether you want to do the practice here or here or here or here, that is your choice. But if you ask me, I can able to say, please try to perform the practice by using all 4 approaches. For example, if I'm going to explain about 10 programs only, out of these 10 programs, you can able to do like this: 2 programs from command prompt, 2 programs from pie chart, and you can able to perform 2 programs from Databricks. So like that, you can able to split, try to get knowledge on all these different IDs or Databricks or command prompt. With that, you can able to work easily as part of our real-time projects. Is it clear? But simple
Yeah,
answer for your
sir.
question, if you want directly, you can able to do the practice on the command prompt.
No, sir. Actually, here why I'm saying command prompt is like my system doesn't support to the external services.
Yeah, that's
So-
what I'm telling you. I'm only telling the same thing. If your system is not supporting, you can ignore that and you can do the practice on the command prompt only.
Okay. I mean,
But
here
for
the code is same in all the cases, but only
No.
the configurations is
Yes, correct.
different, right?
Yes, correct.
According to the environment.
Yes.
Sir, under Python structure, sir, hello.
Yeah, please tell me.
Under Python structure, can I select Python folder under zip file 10.9.5? Yes, sir. Hello.
You are asking about the project structure. Just 1 second.
Yeah, yes, sir.
Okay. Got it. Just I will show you.
Under Python,
Under
Pyspark
Python,
structure.
you need to go to lib directory. In the lib
Yeah,
directory, you can able to see the py4j01095 src.gif. You have to select it.
Then okay.
Click on OK button. That's it. Okay. That's it.
Okay, sir.
Okay. Yeah.
Hello, sir.
Yeah, please.
Sir, I'm getting the output, but before that, I'm getting like a warning. One
Yeah,
shell
that's
did
fine.
not.
I'm also, if you see, I'm also getting the warnings. That's okay. You can ignore the warnings. No issues.
Okay, sir.
Yeah. Okay, whomever completed the setup only, you can able to drop off. That's all for today. In our tomorrow session, we'll discuss about the practice on the Pyspark. And I will share the notes. Morning also I didn't upload the notes only. I will upload the morning notes and the session notes both together into the Infinity. Yeah, someone is trying to ask the question. Please continue.
Sir, for me, Pyspark download like test files. Sir.
Can you please repeat?
మార్నింగ్ మీరు Pyspark టెస్ట్ ఫైల్ ఇచ్చారు కదా సార్ డౌన్లోడ్ చేసి మార్నింగ్
Pyspark నేనేం ఫైల్ ఇవ్వలేదండి. I given the just a URL to you.
Yeah.
With that URL you can able to download the Pyspark automatically.
అది వచ్చేసి నాకు టెస్ట్ ఫైల్ లైక్ లో డౌన్లోడ్ అయింది సార్.
Text file will download again. So it will download like this. You will see here. It will download like this. It will download as a zip file.
అది వచ్చేసి ఓన్లీ టెస్ట్ ఫైల్ రూపంలో డౌన్లోడ్ అవుతుంది. జిప్ ఫైల్ డౌన్లోడ్ కావట్లేదు సార్.
Below it as zip file. Other people is download the zip file or say download the text file.
Zip file only, sir.
Zip file only. That's a direct URL. Please verify the URL one more time, and with that you can able to try for that. Because for everyone it's loading properly, it's a zip file only. If you want, I will ping you that URL one more time.
Yeah, okay.
I will ping in the group chat. Okay, please try that one more time.
Okay, sir.
Second. This is the, see, if you see in the URL only, you can able to see the name also. What is the name we are having? .tst or .tgz? It's a .tgz. So if it is the .tgz, why it will download as test file? It won't load like that. It will load it as a zip file. Might be you are doing some mistake. Please verify that once.
Okay. Can I share my screen once?
Yeah, please share.
Yeah, okay.
What's your name?
Narendra.
I'm giving the permission to you. So please share your screen.
It's visible, sir. Like
It's a zip file and it's not a test file. If you see, what is the type? It's a TGZ file. You need to install the WinRAR software. In your system, you don't have the WinRAR software. Please install the WinRAR. So with that, you can able to perform the unzip on top of this file.
okay.
Please open the Chrome browser. In the Chrome browser, you can able to search for WinRAR download. Search for WinRAR RAR.
Hello.
Yeah, search for WinRAR download. Yeah, take the first one. Yeah, click on that. Download this, and after that, please install it. So with that, you can able to perform the unzip operation.
Okay, sir. Thank you.
Any other questions? Anyone?